Hello everybody, welcome to Marketing Analytics course. This is Professor Swagat Chatterjee from Vinod Gupta School of Management, IIT Kharagpur, who is taking this course for you. So, we have been actually doing this particular course, and we are right now in module 3, where we were discussing segmentation, targeting and positioning, and I will continue teaching on that. This is the last video under segmentation, targeting and positioning, and that is where we will start. So, till now we have actually collected data about people while doing segmentation, targeting, positioning. We collected data about people, and what we did is we have broken the data row wise, I would say, means the human beings based on their preferences, based on their behavior, based on their preferences, and then those who are close to each other, we brought them together, and those who are away from each other, we actually put them into two different buckets, and that is how the clustering is done. Now, coming back to the problem of where we can marry lots of different techniques, that I told while discussing about consumer preferences, that we can actually find out consumer preferences from their behavior, from their choices that they have made. For example, let us say if you have chosen consistently chosen brand A over brand B, I know that there is something in brand A that you like very strongly, that is why you are choosing brand A over brand B. So, I will compare whatever is there in brand A, whatever is there in brand B, and wherever there is similarity, I do not think that will impact your choice, but if there is something which is different in brand A and brand B, let us say the fragrance is different, let us say the color is different, let us say something else, some performance quality is different, you might give lot of weightage to that. That is why you actually choose brand A over brand B consistently. Now, all I am trying to say here, that by focusing on the choice of the consumers, then we can come to know that what is their underlying preferences, what are the things that within there. Now, this is not something that is visible. See, I have always told in the previous lectures or previous videos that you should focus on behavior, because behavior is something that is visible. Now, here in this context, the only behavior is the choice that you have made. Oftentimes, that is the data that we have. Now, if I have only one data, which is your choice data, then that becomes difficult. It becomes difficult to understand that what kind of other behavior you do, and if I do not have lots of behavioral data about the consumers, then I cannot use behavioral segmentation in my segmentation method. So, in that context, what we try to do is we try to analyze something and try to find out the underlying preferences, and as I told just now, that the choice that a consumer made can actually help us to find out the underlying preferences of the consumers. Now, how to do that? In the choice modeling, in what consumers want module, or in the conjoint analysis module, we have discussed about that how I can actually consider consumers data, how can I consider consumers behavioral data, only one behavior, in this case the choice, and how I can find out preferences. Now, let us assume that there are multiple such consumers, and I am able to find out the preferences of each of these consumers. If I am able to find out that, then I should be able to actually find out the segments. Segments means those consumers who have similar kind of preference. For example, let us say in a choice of B school, let us say you are choosing which B school you will go for your management studies. So, some customers, in this case the students, there are some applicants, some students who focus on only ROI. So, whatever I am paying and whatever I am getting back in terms of the monetary figures. Some people focus on the experience as well. Some people probably have a little bit of more preference on the atmosphere, the opportunity of having a startup, the opportunity of doing something extracurricular as well. So, all of these things also for some people it might matter. more matter for those kind of people who might be the first time they are going for a hostel life. So, there can be one group of people who have already had a hostel life or campus life, and they might not focus on one another. So, they might not give more preference on a campus specifically in the second time after bachelor's when they are doing masters. On the other hand, there are another group who probably were day scholars. They used to go to their respective colleges from their home. So, they were always hometown based, and this is the first time they are going for a management study where they will be away from their home. So, they might want a campus. So, the preference of campus might be different for different people. Preference for ROI will be different. Preference for academic load will be different. Preference for industry connect will be different. So, there can be different kind of people in the same segment, overall population of, let us say, students who are interested in doing MBA. There can be several people who might have several preferences. Now, we cannot do a survey to all these guys and ask them that, okay, what is your preference in a 1 to 5 point scale, you just give me that, how much you prefer this, how much you prefer that. Sometimes or many a times it is not possible. So, then what we do is we use that conjoint analysis kind of technique to find out that, okay, given these 4 choices you have chosen A, or given these 4 choices you have chosen D, then that means the preference towards various attributes are this, this and this. Now, if that is the case, then I can also find out there will be some people who will be close to each other and some people who are different from each other. So, that is where I will focus right now. Let us assume that from certain kind of conjoint analysis, we found that this is my data set where these are my customers. So, customer 1, customer 2, customer 3, customer 4 dot customer n, and these are my aspects, aspect 1, aspect 2, aspect 3, aspect m. So, this is basically a n into m matrix, and in this particular data set, each row is each one of the customers preference towards certain aspect. So, this guy's preference towards A11 is written as, let us say, preference 11, then preference 12, then preference 13 and so on. This is actually the preference, how much weightage you give to this aspect over some other aspect. Now, what is important to understand is that I am trying to find out the distance between these two group of people or multiple customers, and we are creating segments by checking how the preference of this customer is close to this customer. So, remember we created a distance matrix, a Euclidean distance matrix in our. So, here I can also find out a Euclidean distance between these two. So, how will be the Euclidean distance? The distance between ith customer and jth customer will be summation of the preference of ith customer on kth attribute minus preference of jth customer minus in kth attribute square of that, and k varies from 1 to m. So, this is the Euclidean and actually square root of that is the Euclidean distance. So, I can find out Euclidean distance for each of the customers, each pair, and then whoever is closer I will join them, and I can do a hierarchical clustering by that. We can also do a k-means kind of clustering, where if there are n number of customers, I can randomly choose 2 or 3 and see that who falls closer to that particular centroid. 2 or 3 centroids I will find out, and if somebody is close to that centroid, I will put them in that particular I would say cluster, and the moment I change the cluster a little bit, if the customers also change, if the customers cluster representation also changes, then that is an unstable clustering. If I go on and doing, and when I reach stability, that means each customer is assigned to a particular cluster or a particular segment, and he is not shifting from that segment. Even if I move the cluster node, he is not shifting from the segment. That is something is called k-means clustering. We can use that also. So, here in this course, In the next probably 10-15 minutes, we will do that. So, if you remember, we have a data which look like this. So, this data was part of our conjoint analysis data, but I changed the E column, the column number E a little bit. The rest of the things remain same. If you remember, the data set had fuel 1, 2, 3. There were 3 types of fuel. Fuel 1 was diesel, fuel 2 was petrol, and fuel 3 was CNG. Similarly, I had capacity 1, 2, 3. Capacity 1 was, if I am not wrong, 8 seater, capacity 2 is 6 seater, and capacity 3 is 4 seater. And then price 1, 2, 3, price 1 was, if I am not wrong, I think 12 lakhs and 8 lakhs and then 4 lakhs or 6 lakhs, something like that. So, you can go back to the, so this was on conjoint analysis, rating based or ranking based conjoint analysis. And here the ratings are given into 1 to 10 point scale. 1 means do not like this model at all, 10 means I like the model a lot. Now, there in that particular problem, we did a regression over the whole data, because we thought our underlying assumption was that our customer base is homogeneous. What is homogeneous? That means they are of similar kind of quality, their focus is same, their preferences are same. So, there is not much difference between customer 1 and customer 2. That is why we have run the analysis on the whole data. But here in this context, I am trying to do something else. What I am trying to do? I am picking up each of the customers data. If you check that each customer, this serial number is actually the customer ID, each customer will have 9 data points. So, each of the customers data I am picking up, I am running a regression on rating with fuel, capacity and price as my x variables. So, each small regression, there are, if you check, there are 60 customers in total. So, then I will actually run 60 regressions. So, if I run 60 regressions and if I do something like this, then what will I get? I will get from customer 1 up to customer 60, I will get their preference for fuel, their preference for, let us say, diesel, and their preference for price. And not only that, actually not only that, I will get their preference. So, this is actually wrong. I will get their preference for fuel 2 and 3 in comparison to fuel 1. Remember that there it is a categorical data, fuel 1, 2, 3 is actually categories. So, keeping fuel 1 as my, I would say as my categorical reference point, we will find out that how much a customer prefers fuel 2 and fuel 3. So, keeping diesel as reference point, how much they prefer petrol or CNG. So, fuel 2 and fuel 3, then similarly I will get, let us say, capacity 2 and capacity 3 and price 2 and price 3. These are the 6 things that I will get for each of the customer. For each customer, each row is one customer. So, I will get for each of the customer, and then I will find out how customer 1 and customer 2 are distant from each other. If they are close, I will put them in the same cell. If they are away, I will put them in the other cell. If I use hierarchical clustering, if I use k-means based clustering, I already told you what kind of algorithm you will use. But this is something that I will create fast. If I create this, the rest of the job is absolutely picking up the code from the previous codes and just run this thing. But this part is something that will be that is new, and that is something that I will do. So, in other words, what I am trying to do here is I am marrying conjoint analysis or regression analysis, whatever you want to name. Conjoint is the mathematical is the marketing name or methodological name. On the other hand, underlying methodology is econometric methodology is regression. So, I am marrying regression analysis or conjoint analysis with clustering in this particular problem. So, I told in the first presentation or in the introductory presentation of this particular course, that marketing analytics is often a smart job. It is often you have to know in your mind that what are the various things that you have in your arsenal, and for a particular problem what kind of such tools you can bring in and work them parallelly or sequentially, so that you can solve the problem. In this particular context, I am using regression and cluster analysis sequentially. In the previous problem, when I was doing previous thing, there was a segmentation targeting positioning using cluster analysis, followed by targeting for which we used basically multinomial regression. You can also use linear discriminant analysis for that in the previous slide, a previous video. And there was only 6 behaviors. If you remember carefully, there were only 6 behaviors, and that is why we only went ahead with factor analysis. But if there are lots of behavioral data you get, then to make those less number of behavior, you can also do factor analysis before doing cluster analysis. So we will give you that as a do it yourself kind of a project, that you can do it on your own, try out on your own, and see that what it comes. Now, there we married basically cluster analysis with multinomial logistic regression. Here we are marrying simple linear regression with cluster analysis. So, let us see what do I have. So, I have opened this week 3 session 5.r file, which is there with you, and the corresponding data file looks like this. I have already shared the data file looks like this. And then what I do is, the first things first, I set my working directory to source file location. I actually have kept these 2 files in the same place, the R file, my global environment and console is clean, and I reading the data. So, the data looks like this, as we have already seen, and in line number 3 what I am doing, see, if I just see the structure of the data, says that this fuel, capacity and price are integer variables. Are they integer variables? No, they are not integer variables. Why? Because there are categories 1, 2 and 3 is actually 3 different types of fuels. You cannot say that diesel is 3 times of CNG, or price is or petrol is 2 times that of CNG. You cannot say that. So, 3, 2, 1 has no meaning, they are just 3 categories, right. So, what will you do then if there are 3 categories, and here it is shown that they are integer variables as per the structure of the data. What will you do? You will change it to factor variable, very good. So, we will change it to factor variable by running the line number 3. See, what did I say? For I in 2 to 4, why 2 to 4? Because second column is fuel, third column is capacity and fourth column is price. So, I will value from 2 to 4, second column to fourth column. What will I say? I will say that data third bracket comma I. Data third bracket. The moment I put a third bracket after data, what it does? The moment I write some data file name and then I write third bracket, it knows that I am doing a subsetting. I wrote a comma means whatever I wrote before the comma, this was the first module, remember, whatever I wrote before the comma are what? The row names, the row numbers that I would use to subset, and whatever I will put after the comma is what? The column numbers, very good, the column numbers that I will use to subset. Now, if I write nothing after the comma, that means I will take all the columns, and if I write something before the comma, then I will take such rows. So, the moment I write something like I, this means that there is nothing before the comma, that means I will take all the rows and ith column. When what is ith column? When I is 2, it is second column. When I is 3, it is third column. When I is 4, it is fourth column. So, that is what I am doing. So, data I is equal to what? The factor representation of data I. So, you pick up data's ith column change it to its factor form and save it back to data comma I, means ith column. So, pick up the fuel column, which is second column. When I is equal to 2, it will pick up the fuel column, change it to its factor form. Factor form means 1, 2 and 3 will now be used as categories and save it back, and that is what I am doing for all the 3 columns. So, that is what I am doing, running this. It is changing my 3 things, fuel, capacity and price, to their factor form. See, these are now factor variables. So, if they are now factor variables, I can run the regression. Now, remember, each of these factor variable has 3 categories. Fuel has 3 category, capacity has 3 category and price has 3 category. When I run a regression, because of multicollinearity issues, at least one, so 2 dummies will be created for each categorical variable. Let us say for fuel there are 3 categories, 2 dummy variables will be created, 1 will be dropped. And why? Please go back and study your linear regressions details about, some a little bit of econometric background is needed. Why? Because there is multicollinearity issue. I cannot use more than, I cannot use all the categorical categories of a categorical variable in my model, because if I use that, they are absolutely multicollinear. They have a multicorrelation, 100% multicorrelation. So, the R square value will probably come as, I do not know, infinite. VIF score will come probably like infinite or something like that. So, that is something that we have to avoid. So, how to avoid that? We drop any one of them. So, in this case, what R will do automatically is R will drop alphabetically whichever is the. So, fuel 1, 2, 3, 1 is alphabetically first, then 2 and 3. So, it will drop that, and fuel 2 and 3 it will give you. So, this is the similar result we have got when we ran the conjoint analysis. So, there are 3 categorical variables, each has 3 levels. If from each of the categorical variable one level gets dropped, that means there will be 6 columns, 6 categorical variables, 6 dummy variables that will be created from these 3 categorical variables. 6 dummy, what is this dummy? For fuel it will be fuel 2 and fuel 3, for capacity it will be capacity 2 and capacity 3, and for price it will be price 2 and price 3. So, I am creating this kind of a column. So, which has 6 columns and 60 rows, and I am creating that using this line. For all the entries as a starting point, I am writing as 0. So, 0 n col is equal to 6, n row is equal to 60, I am creating a matrix. So, this is the matrix looks like this, there are 60 rows, all of them are 0. And I am naming the column names of matrix 1 I am writing as fuel 2, fuel 3, capacity 2, capacity 3 and price 2 and price 3. So, now if I running, and after that if I see that name of the columns got changed. Now, what do? I run the regression 60 times. So, each time with the data of the corresponding guy. So, let us say for the ith guy, remember in this data set, if I am the ith guy, then what is the starting point? Each guy will have 9 observations. So, if you remember, the ith guy will start I minus 1 into 9, so that many observations will be before him. So, ith guy is, let us say 2 is a second guy, that means 9 observations will be before second guy, that means 2 minus 1 into 9, 2 minus 1 is 1 into 9. If I am 5th guy, then 4 observations, 4 customers observations is already there, that means 36 observations is already there, which is 4 into 9, or in other words 5 minus 1 into 9. So, I minus 1 into 9, this many observations will be, these many rows will be before ith guy's observation starts. So, his starting point, that is why will be, if you see carefully what I wrote, here I wrote data I minus 1 into 9 plus 1, that is the first observation of ith guy. And what is the last observation of ith guy? I into 9. So, I run the regression, simple linear regression, LM rating, fuel capacity price, but data is equal to a subset of the data, not the whole data, a subset of the data. How to write a subset of the data? Check it carefully, what did I write? I am just copying this part and pasting it here. Check it carefully, what have I written? Now, I am copying this part and removing it. So, data third bracket and comma, that means a subset of data. Nothing written after comma means all the columns. Now, what did I write before comma? I wrote this. So, I wrote this value, which is if I is equal to 2, that value is 10. If I is equal to 3, that value is 18 plus 1, 19. Up to how much? I into 9. So, the first row number and the last row number, that much rows will be picked up for every I, and that will be going on as I changes, these values will change. So, I am writing for I in 1 to 60 for each of the customer, you first run a regression with the corresponding data set of the customer and save it in fit 1. It is the first job. What is the second job? Now, if let us say I am running it for I is equal to 1. Okay. For I is equal to 1, if I run this, this is how the fit 1 looks like. This is how fit 1 looks like. This is how fit 1 looks like. So, I am saying that now remember there are some values which I consider to be 0, because these guys are not significant, like this is not lower than 0.05, this is not lower than 0.05. So, I can consider this to be 0, this to be 0, this to be 0, this to be 0. So, I am saying that if else, if summary fit coefficients is less than 5, what is this? This is nothing but the p values. See the p values, the p value of fuel 2, fuel 3 and okay, sorry, it should not be 2 to 4, it should be 2 to 6, and here also it should be 2 to 6. So, I will just run once more. So, what is this thing? This is nothing but the p values. See, check the p values. The p values are 0.8713, 0.04169, 0.056, similarly 0.08713, 0.04, 0.05, 0.08. So, I will only consider such values, where these values are lower than 0.05. If they are lower than 0.05, consider the coefficients as it is. If they are not lower than 0.05, consider the coefficients to be 0. So, 2 to 7, 2, 3, 4, 5, 6, 7, that means total 7 things I am running this now. So, 2 to 7. So, in the actual file that will be given to you, this will be edited 2 to 7 and then I run this. So, I run this. So, once I run this, the matrix looks like this. This is the matrix that I got. All the zeros means for customer 2 nothing was significant, for customer 3 nothing was significant, but there are some customers for whom some things were significant and corresponding weightages were written here for each of the customers. It got populated. Now, rest of the things is simple. I will use this matrix to run a cluster analysis. So, first I will convert this to a data frame called DF. DF looks like this, same thing. Now, I will use this DF to run a k-means kind of clustering. So, first I will plot the scree plot. So, this is the code that I have used there also. I will just run it and this is how the plot comes up, and I can see that the kink is in 2. Kink is properly coming at 2. You can probably also use 3 or something like that. So, first I will use clusters is 2. If there are only 2 clusters, what is the meaning I am getting? I will run that and I will see that there are 2 clusters. The first cluster looks like this. These are the average preference of first cluster, and second cluster, this is the average preference. So, first cluster guys, they do not think petrol to be much more attractive than diesel. Diesel is the reference point, fuel 1 is diesel which got dropped. So, these guys do not find petrol to be more attractive than diesel, but they definitely find CNG to be less attractive. Now, this guy is highly sensitive towards fuel. They think they are very much, I would say, diesel conscious. Anything which is petrol they do not like, anything which is CNG they absolutely do not like. So, these guys are very much focused on diesel. These guys are not much focused on diesel. For them, diesel and petrol are not different. The coefficient is 0 and the coefficient for fuel 3 which is CNG is negative, but not that very big. On the other hand, this guy is also capacity sensitive. So, they want big car, 8-seater. So, if it is 6-seater they do not like, if it is 4-seater they do not like at all. On the other hand, these guys are also not much sensitive, 8 and 6-seater is okay, and for 4-seater they do not prefer 4-seater, but that preference difference is not much. Similarly, these guys are price sensitive also. So, in other words, I can say that group 2 is heavily sensitive on all the 3 aspects and group 1 is not so much sensitive in any of the 3 aspects. I can also find out if what if there were 3 clusters. Just check. If there are 3 clusters, then I can find out that okay, this guy is absolutely not fuel sensitive, they are not fuel sensitive at all, but heavily capacity sensitive. So, the moment capacity drops below a level, they become very sensitive, and the moment it becomes price goes up, they become very sensitive. This guy is like segment 2 in the previous one, they are sensitive to everything. On the other hand, group 3 is highly fuel sensitive or moderately fuel sensitive and not sensitive to anything else. So, I can find out different groups who have different kind of sensitivity towards different kind of things, and then if I have some demographic data, I can try to see that what is the demographic data that predicts that whether you will be group 1 or group 2 or group 3. So, is it some specific type of income group or specific type of gender or specific type of cultural background that leads to your price sensitivity or fuel sensitivity or everything sensitivity? We can try to analyze that. For that, you have to use again multinomial kind of regression or LDA that we have done in the last video. So, that is all for segmentation, targeting, positioning. We have done quite a lot of thing. Thank you for being with me. I will come back with a new module in the next video.